Thanks, Joel. Mostly I'm just going to introduce us a little bit and talk about the work that Joel didn't say much about. So, as Joel mentioned, we've been working with Arctic Ider Society on the oceanographic sides of things. I'm from the Center of Earth Observation Science, or CEOS, which is at the University of Manitoba, and we're a relatively large group. We have sort of members who are also part of Fisheries and Oceans and are adjunct professors at the University of Manitoba. We're part of sort of national networks such as ArcticNet, that we've already heard mentioned here today, and part of some international networks such as this little logo that's on the slide, ASP, Arctic Science Partnership, which brings us together with Greenland in particular and other Scandinavian countries to work on some of these issues that are not just localized to the Canadian Arctic, but of concern internationally. I think a central goal of our group, CEOS, is to try to take a systems approach. So we're an interdisciplinary or a multidisciplinary group. We have everybody, we have faculty members and staff who are anthropologists or who work on paleoclimate, some who are atmospheric scientists, some who are biogeochemists, etc. The group got its start, I think, with sea ice, and still has a big focus on sea ice and remote sensing methods, you know, sort of Arctic-wide and pan-Arctic. There's also a strong oceanographic sort of component within the group. Coming to Hudson Bay, I think there's quite a long history of the group working in Hudson Bay. I started in about 2005, and many members of CEOS started working on Hudson Bay, you know, much before that. And we're collectively as a group continuing to put in proposals to the sponsors, to funding agencies, to try to bring more resources to continuing work in Hudson Bay. I mean, we've heard today about how it's an area where the science is still really quite sparse. It's such a vast inland sea, such a vast area, and you know, it really has been inaccessible to the sort of science vessels, to the vessels from which you can do certainly oceanographic work. So really it's only been, there were some very early studies many decades ago, and then long periods of more than a decade with basically no scientific study. So it's a big, over the last 10 years, I would say, CEOS has really made several efforts to get more, to bring more research money and research effort into the Bay. You know, for Manitoba, it's very important to us that we have this bit of marine coastline along Hudson Bay. People forget that we care about the ocean in Manitoba, but it's because we take a lot of pride in having that little piece of coastline along Hudson Bay, and so we're interested in the whole system, I think. Just a couple of projects that I'll say a few words about. These are the two projects on the slide right now are things that have just been funded, so they're sort of not even really at the kickoff stage. We just got the letters saying they were funded, but it's now all, the implementation is still all yet to come. The first one, GenIce, is a project that is focused on using genetic methods to study oil in an ice environment. So as we've heard mentioned today, shipping is a big issue of concern in northern areas, and it became clear that there is really not very much known about how is oil going to behave if there's an oil spill in an ice-covered area. How is that oil going to behave? Is it going to be on how much is going to be on the ice? How could you go about getting it off the ice? What's going to happen long term? Are there bacteria in the ice that could help break down some of that oil? So this project is aimed at investigating those things so we can be better prepared in the event of an oil spill down the road. The second item here, the Churchill Marine Observatory, this project has sort of two purposes, I suppose. One of them is to build a facility in Churchill in which you could experiment with oil and ice. So it would be a closed pool that's isolated, And in this pool, you would bring in seawater, you'd be able to grow ice, and then you would be able to manipulate that to actually study in a controlled way how is oil going to behave in this kind of ice environment. So that's one big part of this CMO. The other part of it is putting out a set of instruments along the major shipping corridor that leaves the port of Churchill, and using that set of moorings or oceanographic instruments to study how sea ice is changing along that corridor, and be able to then tie the sort of changing ice conditions to the amount of shipping, and then ultimately relate that to the sort of potential for future oil spills in the region. So I guess this is a big driver in a way in which CEOS has tried to respond to some of these research priorities that are facing the region. ArcticNet has already been mentioned, and we'll say a little bit tomorrow, I guess, in our IRIS workshop. There are several projects within ArcticNet that are led by faculty members at University of Manitoba. Most of the projects look Arctic-wide. So they are focused on sea ice all throughout the Canadian Arctic, or contaminants throughout the Canadian Arctic, the carbon cycle, and how the carbon processes are relating to greenhouse gases and the global climate change, and freshwater marine coupling. That fourth project is actually specifically focused on Hudson Bay, and has quite a lot of emphasis on Southeast Hudson Bay, the region we're talking about. Joel mostly, I won't say too much about this because Joel introduced a little bit of the work. This is really this fourth ArcticNet project that we call freshwater marine coupling is really the project that has enabled me and my team to come and work in Sanikiluaq, in Inukjuak, Umuyak, and Kuzyk, and most recently this past winter in Shaspi. And these are just some pictures from the field of our various graduate students, another faculty member, Dr. Jens N., who was here last winter and worked with some of you. And so this is a big partnership effort, as Joel said. So in the particular communities, it really requires the combined effort of us from the university and certainly the community partners from the community. I'll say, Joel showed you some of the instruments we're using of ice cores and water samples and CTD profilers. And another aspect is putting in some oceanographic moorings. So some instruments that can remain in the water and collect a continuous record. This helps to fill in the gaps, times when the conditions are too bad for anyone to go out on the ice and make any measurements, and also to expand our spatial coverage. It's very tricky, as you all know, it can be really tricky to be out on the land-fast ice. There are places you maybe don't really want to go to, but maybe we can put an instrument out there if it's not too expensive and collect some scientific data. So this is just early stages of this work, I'd say. My group really just started working with Joel and the Arctic Ider Society in January of 2014. So but I think we're going in the right direction in terms of better understanding the processes that are getting affected by the freshwater and determining the sources of the freshwater, the sort of flux of it through the system, how much it varies from year to year, and again, how much the way in which the freshwater present in the region affects the processes such as ice formation, ice distribution of the ice, the behavior of polynyas that are so important, those kinds of things. The last project that I'll mention is BaySys. It's sponsored by NSERC as well as Manitoba Hydro. And it's something they call a CRD, a collaborative research and development project. It means that the scope and the activities are very much defined by a sort of steering committee that has 50% representation by Manitoba Hydro. So it is a very applied kind of project aimed at principally the priority concerns of Manitoba Hydro. Fortunately, there's a lot of overlap between the priority concerns of Manitoba Hydro and a lot of the concerns that come up here today. You know, we all share these questions about what's the relative sort of impact of hydroelectric development and climate change, and what's that relative impact today? What's that relative impact going to be 20 years down the road when maybe the warming that's occurred from climate change, you know, we've reached a further point in that warming, and maybe there will be a turnover point where climate change effects start to be more important. We know in Hudson Bay already the season of ice cover, of course, has gotten much shorter. We know also, though, that the changes that have been occurring in the ice cover are different in Western Hudson Bay versus Eastern or Southeastern Hudson Bay. So this project, this BASIS project, aims to look at the bay as a whole. So it has a very large spatial scope, and to try to study those two sort of drivers of change together, and try and tease apart, where possible, the specific impacts of hydro changes versus the specific impacts of climate change, because both of those are altering the amount of fresh water that's in the system. Ice melt versus river water, but both of those are really important components and interact with one another. There we go. There are several phases to this BASIS project. It got going this past fall, at the end of September. There was the first cruise conducted. The purple line on this slide sort of shows the overall cruise track. Again, because of Manitoba Hydro being a major sponsor, the work has a strongly sort of Western Hudson Bay focus. The ship left from Churchill and went out to put in a mooring, and then went down towards the Nelson River area and put in some moorings in that region. But then, you know, the steering committee that governs BASIS was made aware of the priorities also in southeastern Hudson Bay and James Bay, and the need for comparable data over in this region to be able to understand the bay as a whole. So although maybe the initial preference would have been to really stay close to Manitoba Hydro's area of interest, they were willing to extend this cruise and at least do a chunk of work over in the sort of James Bay, Southeast Hudson Bay region. So that's what you can see from the cluster of points on the map there. You can see that actually a good chunk of work ended up being done around the mouth of James Bay in particular, and south of the Belcher Islands. And this included deploying a mooring. I think my next slide is going to zoom in a little bit. This just has a picture of the kind of oceanographic mooring that we put in the water near the mouth of James Bay in order to be able to collect what would be the first year-round record of the properties of the water, particularly where it's flowing out of James Bay into southern Hudson Bay and then flowing northward. So this mooring is equipped with a variety of sensors to be able to measure temperature and salinity, and also a sediment trap which will collect the particles out of the water column. So we can look at the character of those particles and be able to ultimately compare them to what was being transported in the past. So we're really happy to have accomplished this mooring, and I think it's going to bring some much needed data for the region. In the winter, the BASIS project is going to be focused around the Nelson River estuary, and measurements to be made there. And then next spring, in June and July, the Amundsen vessel will come back into Hudson Bay. If you have a look at the map, you see this crazy zigzag drawing of lines on there. that's the sort of wish list of scientists, all the places they really want to go and collect samples and make measurements in Hudson Bay. It's way more than what can be done in the 4 weeks that is likely to be available. So in December will be the first meeting to try to wrestle and sort out what it is we're really going to do on that cruise. Those of us who've been working in this region are doing our best to make sure that it gets on the agenda and that the Amundsen does come down into James Bay for what would be the very first time. We have begun discussions with the captains, and they are willing to come down into James Bay, although it hasn't been done before within this sort of by the Amundsen. But there is a line of soundings, so they're extremely careful about where they bring the Amundsen in because of the hydrographic, the limited bathymetric data for so many places. But certainly we want to make sure that that happens. So that's sort of to be determined, but I think there's a tremendous amount to be gained by being able to bring that ship in and take advantage of the wealth of scientific expertise that's on board. The ship also has a helicopter and a barge and Zodiac, which would allow it to approach the shoreline and try to connect some of the inshore work and this offshore work. So hopefully this will all come together. Thank you.
Thank you, Zuzu. I think it's such a clear example of how this working together can really leverage a lot more. The fact that we developed this network of research with hunters in the 5 communities, and that then they were working in the Nelson River on the west side, and that work going on at the same time in east and west can really help get the big picture. And then as a result of them seeing that this was ongoing and a priority, we're able to negotiate things like a big ship coming down into James Bay, and to be able to think about the big scale modeling that they're doing for Hudson Bay and how we can contribute to that. And so by coordinating the research between these 5 communities and then helping leverage in the bigger partnerships. And then I think the next thing, so going from the small scale to the big scale. And then the next side of that too, a lot of what's motivated this has been work with Shasby as well on the eelgrass work. And so how do we bring, as a result of the Special General Assembly, a lot of this talk about bringing the Amundsen into James Bay kind of materialized. But then how do we also connect the different trophic levels? And so we've been working with Shasby to do the oceanographic work that we talked about. And that's a big important component of understanding what's happening to the eelgrass as well. And so it's important to coordinate this oceanographic work with the ecological work to understand what's going on. And that's our little segue to Fred Short's talk, who's going to be talking about the eelgrass work here in James Bay.